Okay. Okay. Good evening, one and all. First and foremost, I would like to welcome you all to this 5 days hands-on training program on density functional theory calculation using Gaussian software. So before starting the session, just let me brief out what we are going to learn throughout this workshop and what are the things we are going to cover. And myself, Dr. Shivakumar, the director of Vidyoti Edutech Private Limited. So this workshop was organizing by Vidyoti Edutech Private Limited. So currently, I am working as a postdoctoral research fellow at Department of Chemical Engineering, Pohang University of Science and Technology, South Korea. Okay, so I just want to brief out what we are going to learn in this training program. So it is a 5-day hands-on training program. So on day one, we are going to discuss about some basic concepts of DFT, and then we are going to demonstrate you how to download and install the software which is needed to perform the DFT calculation. And then we are going to demonstrate you the basic usage of the software, like what are the different modules which are available in the software, then how to use those, the complete interface of that software. And then we are going to demonstrate you how to perform the geometry optimization by using a DFT method and artifact method, and then how to analyze the output data. And we demonstrate you like how to calculate and do the analysis of electron density surface or molecular electrostatic potential surface, all those kind of things. On day two, we are going to discuss about various spectral calculation, like IR spectra calculation, Raman spectra, like Raman optical activity spectrum, or like VCD spectrum, like vibrational circular dichroism spectrum, or to analysis of NMR spectra. All those things we are going to cover on day two. On day three, we are going to talk about UV spectrum, then ECD spectrum, then calculation of these frontier molecular orbitals like HOMO-LUMO, and finding out the energy gap between your molecule, HOMO and LUMO. And then we are going to discuss about the calculation of various chemical reactivity parameters like chemical softness, hardness, ionization energy, or electronegativity, electronaffinity. There are various parameters are there. So how to calculate those parameters, all those kind of things we are going to discuss. And on fourth day, we are going to talk about natural bond orbital calculation. Then we are going to discuss about the how to calculate the salvation energy of a molecule, then bond formation or dissociation energy, then how to calculate the Gibbs free energy of a chemical reaction. And after that, we are going to discuss about how to perform the DFT calculation at different temperature, pressure, pH level. Then how to use, because while performing the DFT calculation, we are going to use a basis set and functional. So we are also demonstrating how to use the mixed basis set, like multiple basis set. Then how to perform the batch calculation, all those kind of things. On fifth day, we are going to talk about the IRC calculation, like intrinsic reaction coordinates. By doing the IRC calculation, so you can find out the transition state, reaction path, and you can analyze the mechanism of your chemical reaction. And then we are going to demonstrate you how to perform this PES calculation, potential energy surface, or you can call it as a scan calculation. And then how to perform the stability calculation. So we are going to learn all those kind of things. Okay, so with this brief introduction, I will start the session. In today's session, we are going to do three things. The first thing is we are going to discuss about the basic concepts of DFT. And the second thing is the installation of software and the basic usage of the software. And then the third thing is we are going to perform the geometry optimization. Okay, so let's start. First, we'll discuss about the basic concept. Let me share the PPT. So can anyone confirm me that whether can you see the PPT or not? Write it in the chat box. Okay, perfect. Okay, so in this lecture, so I will keep like a lecture as small as possible. Within 20 to 30 minutes, I will finish. So because we will focus more on the hands-on training rather than the theory part. So, but we need to understand some basic concepts to perform those practical session. In this lecture, so we are going to discuss about like what is the quantum mechanics, what is the molecular mechanics, what is the DFT, then what is the difference between them. So what are the basis set, what are functionals, then how to choose the basis set, then how to choose the functional, then why should we need to perform the DFT calculation, how exactly this DFT will work. So we are going to discuss all those kind of things. So let us move on to the next slide. Yes. So in this slide, let's try to understand like what is quantum mechanics and what is molecular mechanics. So this both quantum mechanics and molecular mechanics are two different approaches, so which are used to study the and to understand the behavior of your molecules and their interaction at atomic level. Okay, but these quantum mechanics and molecular mechanics are different from each other in their various factors. So now let's try to understand like how they are different from each other and when to use these quantum mechanics and when we need to perform the molecular mechanics calculation. So on the basis of like a fundamental basis, the basic difference is the quantum mechanics is based on the principle of quantum theory. So because what does quantum theory tells that? So like it describes the behavior of your particle at atomic and subatomic level. Okay, so but whereas this molecular mechanics is based on the classical mechanics. Okay, so it uses the empirical and semi-empirical force field to model the behavior of your molecular system. And this like quantum mechanics deals with the properties and behavior of like individual atom and like subatomic particles like electron, proton, neutrons, and how the interaction between them. So that is what we'll get the information by using the quantum mechanics. But whereas these molecular mechanics focus on the interactions and dynamics of atoms and molecules, treating them as a classical particle. So it won't focus on the subatomic particle or individual atom. It will consider the whole system as a classical particle. So without considering the like quantum effect. So that is the main difference between quantum mechanics and molecular mechanics. And when it on the basis of like this mathematical framework, so you already know that this quantum mechanics uses the wave function. So because it is based on the principles of quantum theory, so quantum theory works on the basis of wave function, right? So it uses the wave function means Schrodinger equation, and it will use some like operators to describe the states and dynamics of a particle. So here the wave function is the main parameter in the quantum mechanics. So whereas in case of like molecular mechanics, it won't uses any kind of force like work function, and it won't uses the Schrodinger equation. So instead of that, it will focus on the force field. So the molecular mechanics uses the force field. That force field describes the overall potential energy of the system as a function of the position of your different atoms which are present in the system. So when it comes to the accuracy, so which one will give the more accurate result, either quantum mechanics or molecular mechanics? So if you compare, quantum mechanics will give a highly accurate description of your molecular system, and it will account for the overall electronic structure, the energy levels, or the position of the particles and their momentum. You will get all the information. But molecular mechanics also provides the good result, but when it compares to the quantum mechanics, the accuracy is quite less. But whatever the result we are getting from molecular mechanics, so it is more than sufficient to study the many like especially when it comes to the large molecules like biological molecules or like macromolecular complex. In that case, molecular mechanics is more preferable, because if you perform the calculation by using the quantum mechanics for the large molecules, it will take a lot of time. But whereas these molecular mechanics, it will take less time. Okay, so we have to consider all the factors. Okay, so because these quantum mechanics calculations are computationally more costly, especially like your large molecules or some biomolecules, proteins, nucleic acid. If you're studying such kind of molecules, it is highly costly. Okay, but this molecular mechanics is computationally less costly than your quantum mechanics, and because of that, it is suitable for to study the large system. Okay, so in terms of application, so what are the studies we can do by using the quantum mechanics, and what kind of studies we can do by using the molecular mechanics? Like this quantum mechanics is used for the detailed studies of your electronic system. Okay, like their chemical reactions, electronic property, the spectroscopic properties at the quantum level, like atomic level. In that case, we are going to use the quantum mechanics. Whereas this molecular mechanics is used to study MD simulations, or if you want to do some kind of in the area of like drug discovery, or structural biology, if you want to study the mechanism of protein binding, all those kind of things. In that case, we are going to use the molecular mechanics. Okay. So like if I want to tell it in a simple words, quantum mechanics is used when precise electronic details are required. Whereas molecular mechanics is preferred for studying the larger system where a classical approximation is sufficient. So that is what the main difference between your quantum mechanics and molecular mechanics. I hope it is clear to you. So like what is the quantum mechanics and molecular mechanics and the difference between them. Okay, if it is clear, let's move on to the next slide. Yes. So now I told that like this electronic structure is very important. We have to study, because by studying the electronic structure, we get various properties. Like we are using the quantum mechanics and molecular mechanics to study the electronic structure, like electronic theory. Now the question will come. So why this electronic structure theory is important? Right? So because the most information you want to know about your system is associated with the two factors. So it depends on the two property, that is electron density of your system, and the second one is the electron energy of your system. So if you find out what is the electron density and electron energy of your system, so you can calculate the other properties which are related to your material. Because by knowing the electron density of your system, you can calculate the properties like their dipole moment, charge distribution, vector properties, their bond angles, bond length, various properties you can calculate. Similarly, by knowing the electron energy of your system, you can predict the properties like potential energy surface, molecular geometry, their bond energies, their barrier height, like how the activation energy is there, transition state energy is there, and various spectral properties. You can study all those kind of things by applying the Born-Oppenheimer approximation. Therefore, this electronic structure theory is a very important to understand the electronic structure of your system. I hope it is clear to you. Let's move on to the next slide. Yes. So now we discuss like why this electronic structure theory is important. Yeah, it is important. We can calculate the various properties if you find out this electron density and electron energy. Now the question will come. Then how we are going to calculate that electron structure? Then how you are going to determine the electron density and electron energy of your system? Right? So the answer to this question is very simple. So you can calculate the electron structure of your system using the wave function theory, right? So use the wave function theory and you can calculate. So whenever we are going to talk about the wave function theory, so we talk about one famous equation, that is the Schrödinger wave equation, right? So by using the Schrödinger wave equation, you can calculate the electronic structure of your system. So this is the Schrödinger wave equation, and this is like short form of Schrödinger wave equation. So here, the H cap indicates the Hamiltonian operator, and the psi indicates the eigenwave function, so that it will give the information about the set of solution for your Hamiltonian. So whereas this Hamiltonian operator, what information it will give? So it will give the information regarding the kinetic and potential energy of all the particles which are present in your system. So that information will be given by this Hamiltonian operator. Okay, and the E indicates the overall energy of your system. So now the question will come. So when you can calculate the electronic structure of system by using this Schrödinger equation, then why should we need other theories, right? Why should you need DFT calculation? We can calculate. Already we have the Schrodinger equation. So why should we need one more theory? We don't want, right? Even we no need to calculate the theoretical studies, directly can use the Schrodinger equation and you can find out the electronic structure property of the system. But here the thing is, so you can use the Schrodinger equation to solve the one electron system. Okay. So one electron system is nothing but like the system which contain only one electron. For example, you can consider hydrogen. So there is only one electron present in the hydrogen. So in that case, we can easily solve the Schrodinger equation without any difficulties. But it is very difficult to solve this Schrodinger equation for a multi-electron system. Like, for example, you can consider helium, lithium, or anything. So for example, a simple multi-electron system, I'm going with the helium. So there are 2 electrons there. So it is very difficult to solve this Schrodinger equation for this helium. Why? Because in your multi-electron system, we need to solve the Schrodinger equation for like each electronic part. So because of that, it is quite difficult to solve. So therefore, we are using some of the theoretical model to solve the electronic structure of the multi-electronic system using the Born-Oppenheimer approximation. So that's why we are using some theoretical models to calculate the electronic structure of your system. So I said we are going to use some theoretical models. Now try to understand like what are the theoretical models, what kind of theoretical models we use to calculate the various electronic properties of your system. So a theoretical model is nothing but it is a way to model your overall system using a specific set of approximation. And these approximations are combined with the algorithms. So we are going to use some kind of algorithms. So this approximation will combine with the algorithms and they are applied to the atomic orbitals. And those atomic orbitals are defined by the basis set in order to compute the overall molecular orbital and the energy of the system. So later we'll understand what is this basis set, functional, everything. After some time, we're going to discuss about that. Okay. I hope it is clear to you what are theoretical models. This kind of like algorithms, okay, like set of the models which we are going to use perform the electronic structure to calculate the electronic structure of your system. And generally, we are going to use like 3 types of theoretical models. So they are like ab initio method, or you can call it as like semi-empirical method. And the third one is the density functional theory method. Okay. So now the question will come. There are 3 models are there. Which model is the best one? So which one to choose? Okay. So the selection of this theoretical model depends on the size of your system and the level of approximation you want. So depending on that, you have to choose. So which model is best for your system? Now let's try to understand each model one by one. The first one is the ab initio method. You can call it as ab initio method or ab initio model. So this ab initio method will do the computation based only on the theoretical principle. We don't consider any kind of experimental data. So only based on the theoretical information, it will do the calculation. Okay, so here we like numerous methods have the same basic approach, but they are different in their mathematical approximations are used to perform the calculation. Okay, very simple. In ab initio method, we don't give any kind of experimental information. So just we are going to use our structure and we are just doing the calculation based on the complete like theoretical knowledge information. And it will take a lot of time to complete the calculation. So it is like computationally costly method. And if you give like Hartree-Fock, so Hartree-Fock is one of the method, best ab initio method to perform the your theoretical studies. Okay, so you can consider Hartree-Fock is one of the example for the ab initio method. And the next one is the semi-empirical method. So the name itself telling that semi-empirical, right? So empirical is nothing but calculation, theoretical calculation. Semi means like off you can take. So in this method, what we will do to perform the, to determine the electronic structure of your system. So it will consider some information from the experimental data, some information from the theoretical data. So it is a combination of both experimental and theoretical data. Whereas ab initio, it is completely depends on the theoretical information. Okay, it is not interested in experimental information. But when it comes to the semi-empirical method, so it will consider some information from the theoretical, some information from experimental. Okay, so that is the only difference between the ab initio and semi-empirical method. And Zindo is one of the best semi-empirical models so far. If you want to perform the semi-empirical calculation, you can go by using the Zindo model. And this semi-empirical method is useful for if you want like large system, like a big system for the simulation or DFT calculation. In that case, you can use for the semi-empirical method. And the next one is the DFT method. So DFT is nothing but density functional theory. So nowadays, this DFT is becoming very popular. So because whatever the result you are getting by performing the DFT calculation, so they are comparable to the results you got from the AB initio method or from semi-empirical method. But if you perform calculation by using the AB initio method, it will take a lot of time. But if you use DFT method, you can save that time compared to AB initio method. And if you compare the accuracy, there is no much difference in the accuracy. So whatever the result you are getting from by performing the DFT calculation, so those are comparable to the ab initio method. So that's why people are preferring the DFT calculation. B3LYP is one of the best example for the DFT method. So in next slide, we are going to talk a detail about the density. Like we are going to understand, talk about like what exactly the DFT, all this kind of thing. Yes. So now let's try to understand what is DFT. Okay. So I already told that previously we talked about the two mechanism, right? Like quantum mechanics and molecular mechanics. So DFT belongs to the quantum mechanics. Okay. So it is a quantum mechanical method used to study the molecular and electronic state system of your material. So like to study the electronic structure of your material at the electronic level. So here the core idea is what happens if you focus directly on the quantum mechanics. So there is a slight difference between the quantum mechanics and DFT calculation. So in quantum mechanics, what happens? So we are using the Schrödinger equation to solve the your system. And in Schrödinger equation, what it will focus on all electronic part of your system. But in the DFT, the core idea is we are not going to consider this is individual electronic part. Okay. So instead of that, so we are considering the whole electron density as a primary variable. Okay. So if I want to make it a simple statement, so DFT does not calculate your conventional wave function, but rather it will derive the electronic distribution of the system. So what does it mean? So because if you talk about your conventional wave function, that is traditional quantum mechanics, it is based on this Schrödinger equation. So here the primary quantity of interest is the wave function. So we focus on the psi value. And if you calculate what is the psi function, then it will provide the complete information of the quantum state of your system. Right? It will give you information about the probability of finding the particle at various position and state. That is like Heisenberg uncertainty principle. But in DFT calculation, what happens? So it uses slightly different approach by focusing on the electron density. So which is the function of only 3 spatial variable, regardless of the number of electrons. Let's consider your system has like 20 electrons. So it won't care about all the individual electron. So it will consider all the 20 electron as a overall electron density of those individual 20 electrons, and it will calculate the electronic structure of your system. Why? So because already we discussed that it is quite difficult to solve this Schrödinger equation for the multi-electron system. Why it is hard? Let's consider hydrogen. So how many electrons are there? 1 electron, right? So hydrogen contains 1 electron and 1 proton. So therefore, the degree of freedom for the hydrogen is equal to 6. Why? So it has like electron has 3 coordinates x, y, z. Proton has 3 coordinates x, y, z. Therefore, the degree of freedom for the hydrogen is equal to 6. Then it is quite easy, you can calculate easily for the hydrogen. But let's consider for one more example, let's consider oxygen. So how many electrons are there? 16, right? You just make it 16 electrons are there, total like 8 plus 8, 16. And if you like 16 into 3 coordinates, 48. So the degree of freedom is equal to 48 along x, y, z. So then it is very difficult to solve the Schrodinger equation. So see, this is how the interaction will take place. Let's consider this is the one electron of your system. So this electron can interact with this electron, or it can interact with this electron, all the other electrons which are present in the system. Similarly, this electron can interact with all other electrons which are present in the system. And now if the equation focuses on the individual interaction, it will take a lot of time. So if you solve the Schrodinger equation, you need to find the electronic structure, how the electronic structure of your system changes when this electron interact with this electron. Then how it will changes when this electron interact with this one. When this electron interact with this one, it is quite very difficult. Okay. So instead of that, what it will do, it will consider all the electronic system as the electron density. And it will calculate the overall electronic structure. And then it will integrate for the individual electronic part of your system. Let's consider, if I want to explain it in a very simple way. So let's consider there is one classroom. So in classroom, there is one student, only like, let's consider is a Kaushik, is only one student is there. So then the chances of noise is 0, right? So he can't interact, he can't talk with anyone. But let's consider there is a one more student will enter to the classroom. Let's consider Pushpak. So now he has only one chance. Either he can sit quietly or he can interact with Pushpak. Let's consider there is one more student will enter the classroom. Now there are 3 students are there. Now he has like one more option is created. Either he can interact with him or he can interact with him, right? Similarly, he has 2 options. So as the number of electron increases, the interactions also increases, electronic interactions. Then it is quite difficult. So that's why it is quite a difficult, like it is very simple, right? Let's consider. So there are total 4 students are there. And there is some noise is coming from that classroom. And it is very difficult to find out that like there is like 90%, 100% of noise. In that 100% of noise, if you want to find out what is the percentage of noise created by Kaushik, what is the percentage of noise created by Pushpak, or what is the percentage of noise created by Ritvik, it is very difficult. But you can tell that what is the overall noise. So here also, so we are going to predict the overall electronic system instead of individual electrons. So that is the main core idea of the DFT. And now the question will come, how these all properties are we are going to calculate. So here I'm telling that we are going to calculate focusing on the electron density. And we are going to calculate. How we are going to calculate? So the properties of your many electron systems are determined by using the functionals. Okay. So we are using some types of functionals to calculate these properties. So now the question will come, what are functionals? Now let's try to understand them in the next slide. Yes. So functional is a function of another function. Very simple. So functional is a function of another function. So that is, you can tell like f of x. So f is one function, x is another function. So x is the function of this f, small f, this small f is the function of this capital F. So in simple term, a functional is an equation or algorithm that tells you how to calculate the energy of your system by using the electron density. So in the DFT calculation, the functional is the electron density, which is the function of space and time. Okay, so the main functional is the electron density. And this is the function of space and time. So now the question will come. So we are focusing on the electron density. What is electron density? Electron density is nothing but the distribution of all the electrons in your system. Okay, so now these functionals are classified based on their accuracy level or complexity, based on, like, you can call it as like a Jacob's ladder. So based on the Jacob's ladder hierarchy, these functionals are organized into like different types, like based on like how their accuracy is there, complexity is there. Okay, usually they are classified into 5 different types. The first one is the LDA. So LDA is nothing but local density approximation. So this functional depends only on the local electron density of the system. So it will assume the electron is in the uniform state, like your Jellium model. usually these kind of functionals are preferable. So when your system is like slowly varying densities, like for example, you are going to study some kind of solid materials, in that case, this LDA function is more preferable. Okay, for example, you can just see here LDA. So these are the some of the example functional like SVWN, PZ81. So these are the some of the example for the LDA functional. There are many are there. So I just for the reference have mentioned 2 examples for the LDA functional. Okay, and the next one is the GGA. GGA is nothing but generalized gradient approximation. So here it depends on the both local density and its gradient. So that is the main difference between the LDA and GGA. So this LDA depends only on the electron density of the system, like local electron density of the system, whereas this GGA depends on the both local density of your system plus its gradient density. Okay, and it will improve because of that, because it is considering 2 factors. One is the local density, another is the gradient density. So because of that, it will improve the accuracy of calculation over your LDA. So this GGA function will give more accurate result compared to the LDA, but at the same time you have to keep it that, so it will take more time to complete the calculation compared to the LDA. So these type of functionals are better for your molecular system, like organic molecules or inorganic molecule compound. If you want to study the, in that case, these GGA functions are more preferable. For example, GGA, you can see it here. So PBE, BLYP, PW91, these are the some of the example for the GGA functions. And the next one is the meta GGA functional. So meta GGA function, these are like extended version of the GGA function. So here it will depends on the 3 factors. So it depends on the density, local density, then gradient of the density, and it also depends on the kinetic density of your system. So LDA depends on only local density, GGA local density plus its gradient density. So meta GGA depends on local density, its gradient density plus kinetic density. So the number of factor consideration is increasing here. So the number of factors are increasing means whatever the calculation you are getting, so those are more accurate compared to your LDA and GGA. And it, because it will give like more refined information about your system. Like it will offer say a balance between the accuracy of calculation and also the computational cost. These are the some of the example for the meta GGA function, like TPSS, M06L. These are the some of the example for the meta GGA functional. And the 4th one is the hybrid functionals. So hybrid functionals means it is a mixture. So it is a mixture of your GGA, meta GGA, and artifact. Means LDA. You can artifact, you can consider it as a LDA. So it is a mixture of the some portion of the artifact exchange correlation and some portion of the GGA or meta GGA exchange correlation. And it will give more accurate results compared to LDA, GGA, and meta GGA. And it is one of the widely used functional in your quantum chemistry or material science calculations. And for if you talk about the example, this B3LYP, PBE, CAM B3LYP, M062X, these are the some of the example for the hybrid functionals. So usually if you go through the papers, in most of the times they will mention these hybrid functionals. Sometimes you will get GG also, some people will mention LD also, but whenever you'll go focus on like organic and inorganic molecules or metal complexes, usually they will mention like B3LYP functional. They didn't mention that they have used the hybrid functional. Instead of that, they will mention that the B3LYP. So B3LYP is the one of the type of hybrid functionals. So this is the main heading. Under that, there are like more than 20-30 functionals are there. So depending on the type of system, you can choose. But most probably either we go with the B3LYP or PBE. And the 5th one is there is one more is there. You can call it as like a range separated functional, or you can call it as the double hybrid functionals. So here, like along with these parameters in hybrid, what we are going to use, we are going to consider the Hartree-Fock and we are going to consider the GGR, meta GGA. Along with that, here we are also going to consider the second order perturbation theory. Okay, so in double hybrid, what we are going to do? So we are considering the Hartree-Fock information, then GGA and meta-GGA correlation also. Along with that, we are going to consider one more extra factor, that is the second order perturbation theory. And because of that, it will take more time to perform your computational calculation. But at the same time, whatever the results you are getting, so those are like highly accurate. So these are the some of the examples for the double hybrid function like WB9, 7XDs. So for example, let's consider if you're going some for like metal complexes, in that case, larger molecules, these double hybrid functionals are more preferable. But when you're going for like simpler molecules, organic molecules, in that case, hybrid functionals are more useful. So you have to decide, you can change the functional depending on the type of your material, what kind of material, whether it is like solid materials or organic or inorganic materials, or whether it is like a 2D material, like you are going with like M.Sc or graphene material. Okay, whether it is a semiconductor, insulator, depending on that, we have to decide. So which is the best functional and which is the best basis set. I hope it is clear to you, like what is the functional. So how exactly it will work, then what are the different types of functional. Now let's move on to the next slide. Okay, so in this slide, we are going to talk about the basis set. Okay, so first try to understand what is basis set. So basis set is a wave function. Okay, so that describes the shape of the atomic orbitals, which gives the information about the shape of the atomic orbitals. So here, because the molecular orbitals are computed using the selected theoretical model by linearly combining the atomic orbitals present in a system. And you know that there are like two types of orbitals are used to describe the atomic orbitals. Like one is like slatted types of orbital, and the second one is the Gaussian type of orbitals. This slatted type of orbitals will describe the shape of your atomic orbitals more closely compared to the Gaussian type of orbitals. Okay, if you want this slatted type will give the more accurate result compared to the Gaussian type. But usually when we perform the DFT calculation, we are going to prefer the Gaussian type of orbitals. Why? So because it has some advantages over your slatted type of orbitals. So because this computation of this Gaussian type of orbitals is much easier compared to the slatted type. If you want to, in fact, like it is like faster to compute the several your GTOs, like Gaussian type orbitals in combination when compared to the computation of only one single slatted type of orbitals. So that's why usually when you are going to perform the DFT calculation, we prefer the GTOs type of orbitals compared to the slatted type of orbitals. Okay, so these basis sets are classified into like different types. So there are like more than 10 or to 15 types of basis sets are there. So but here in this lecture, I have going to discuss only some of the important basis set types. The first one is the minimal basis set. Okay, so minimal basis sets are the like simplest and smallest basis set. So they use only one function to represent the atomic orbitals of each atom. For example, you can consider STO3G is one of the example for the minimal basis set. And the next one is the split valence basis set. So split valence basis set provides more flexibility by using the more than one basis function, because here in minimal basis set, we are going to use only one function. But in the split valence basis set, here we are going to use two types of functions to represent the valence orbitals. Okay, for example, you can consider 321G or 631G. Those are the example for your split valence basis set. The main idea of using the basis set is we are going to represent the valence orbitals by using the basis set, like how many electrons are there in the valence orbitals. All those kind of information we are going to calculate by using this basis set. And the third one is the polarized basis set. So we are going to use this polarized basis set to add the polarization function to the basis set, which account for the like why we need to add the polarization function. So because there may be some kind of distortion of electron cloud. Okay, so in the presence of other atoms. So for that purpose, to avoid the distortion of electron cloud, we need some kind of polarization function. For that purpose, we are going to add the polarization function. Such kind of basis sets are known as the polarized basis sets. And the next one is the diffuse basis sets. So here, these diffuse basis set, they have include some like extra functions, like with the small exponents to describe the electron distribution, overall how the electrons are distributed in your system. So because which is very important for the anions, or like if you want to study some kind of excited states, or like molecules with lone pair of electrons or electron rich region, in that case, these diffused basis sets are very, very important. So while performing the calculation, still I will explain. So what exactly is polarization, what is the diffusion, how to choose that. So how to decide whether we need to use the polarization basis set or not, how to use the diffuse basis set or not. So later I will explain you while doing the calculation, hands-on training. And the next one is the correlation consistent basis set. So these kind of basis sets are highly useful when you are going to perform this Hartree type of Hartree calculation. Okay, so by using this correlation consistent basis set, you can improve the overall accuracy of the your calculation. So these are the 5 main important types of your basis set. But along with these basis set, there are some other types are there, like a double zeta basis set, triple zeta, and quadruple zeta basis set. So what is the difference between this double zeta, triple zeta, and quadruple zeta? So in double zeta basis set, it uses like 2 sets of functions. It uses 2 sets of functions to describe the valence orbital. Along with this 2 function, it will use the polarization function. That is the difference. So double, the name itself tells that double zeta means it will use the 2 functions to describe the valence orbital of your system. Along with that, it will use one more function, that is the polarization function. In the triple zeta basis set, it uses 3 sets of functionals to describe the valence cell, plus it will use the polarization function. In all double zeta, triple zeta, quadruple zeta, this polarization function is common. All the 3 types have the polarization function. Along with that, double zeta has the 2 type of functions, triple zeta has the 3 type, quadruple zeta has the 4 types. So why they are using those functions? To describe the valence orbital of the system. Very simple, okay? The main use of this basis set is to describe the valence orbitals of your system. That is the main role of the basis set. Now let's move on to the next slide. Yeah. So applications of DFT. So now the question will come, why should we need to perform the DFT calculation? So you can do a lot of studies by performing the DFT calculation. Let's consider you are from the material science background. Okay. So what are the studies you can do if you are from material science background? Like you can predict and study the electronic properties of your system. You can study the magnetic properties. You can study the optical properties of a new material. So before you synthesize that material, you can predict all their electronic, magnetic, and optical properties. And you can analyze their surface interactions, such kind of like you can study the adsorption studies, catalysis studies, all kind of studies you can perform by doing the DFT calculation. And let's consider if you're from a chemistry background. So you can determine the stable conformation of your structure. You can find out what is the reaction pathway. You can investigate the overall mechanism of your reactions or catalytic process. You can design new catalyst by performing the DFT calculations. Even you can predict and interpret various spectral properties like NMR, IR, UV, etc. And let's consider if you're from a physics background, you can study the electronic properties of solid materials. Like you can find out their band structure, their density of state, projected band structure, projected density of state, how the charge transfer is going on. Okay. Even you can predict the all properties of your nanomaterials, nanotubes, quantum dots. Even you can investigate the magnetic properties, mechanical properties, or the optical properties of the solid materials or 2D materials. And let's consider if you're from biological or medical science. In that case, you can predict the interaction between your drug molecules at atomic level. And it will be useful for to design a new drug molecule. Even you can predict their electronic structure, their mechanism of enzyme reaction. And even you can predict the how these changes, for example, folding, defolding of protein will change the overall properties of that biomolecule. And let's consider if you are working in the area of like environmental science. In that case, you can predict the how the mechanism of this pollutant degradation is taking place. Okay. And if you know that one, it is highly useful to design the more effective catalyst for the environmental remediation. And like even if you're like working in the area of like energy field, so by performing the DFT calculation, you can design the better batteries, photovoltaics, fuel cells, semiconductor materials. You can study the band gap, all those kind of how this charge transfer is taking place. You can find out the efficiency and stability of the material by performing the DFT calculation. So like that, if I talk about that, there are wide variety of applications. So there are multiple applications of there by with the DFT calculations. Okay. So, but this I'm going to just stop this lecture. So because I want to focus more on the hands-on training. So I think this much of basic information is sufficient to go ahead. So if you have any questions so far related to this lecture, so please write it in the chat box. So now I will give like 3 to 5 minutes. So if you have any questions, you just please write it in the chat box. So any questions related to molecular mechanics or quantum mechanics, DFT, basis set, functionals, okay. If you have any questions, please write it in the chat box. If you don't have any questions, if everything is clear, then type Y in the chat box. So I can start the next topic. Okay, I think there are no questions. Okay, so let's begin with the next topic. I'll just close this one. So there is a question, is it helpful to calculate the density of state? So for density of state means usually you will calculate for the like solid materials or like 2D materials. And in that case, like density of state, better I will suggest to use a quantum espresso or Burai or VASP. So those are more preferable. So this Gaussian is more preferable for like organic molecules or like small metal complexes like organometallic compound. So it is good for, Gaussian is good for such kind of calculation. If you need like band structure, density of state, that better to go with the quantum espresso or Burai or VASP or a material studio. Those are the best option. And are the functionals approximations like linear terms in molecular mechanics? Yes, there is a question. So like they're asking like when we talk about this molecular mechanics, we talk about the linear tones. Yeah. So how we use the linear tones in the molecular mechanics? So when it comes to the DFT calculation, we need like functionals. Okay. So to calculate the overall properties of your system, we are going to use functionals. And there is one more question, using electron density, what all the electronic properties we can calculate? Electron density, you can calculate their various properties like vector, bond angle, bond length, charges, Mulliken charges, their electrostatic potential, all those kind of properties you can calculate. So I will explain that. Even with hands-on training, when we perform this optimization, energy optimization, I will show. So we are going to calculate the electron density. From that, we are going to calculate various parameters, like what is the charges on each atom, how the charge transfer is taking place, Mulliken charges and their vector, dipole moment, bond length, bond angle, everything we are going to calculate. So how it is useful in biomolecules? So biomolecules means it depends on the what kind of studies you are going to do. Like if I take biomolecules, it is a like broader term, right? So I can, biomolecules means I can talk about the proteins, I can talk about enzymes, peptides, carbohydrates, nucleic acids. Okay. So when you talk about these proteins, enzymes, in that case, we have to focus on more on like molecular mechanics instead of quantum mechanics. So for that, molecular mechanics is more preferable for biomolecules. If you want to study the particularly biomolecules like protein, enzyme. But let's consider you are working in the area of like drug discovery. And if you want study that, how that whatever you have designed one drug molecule, like small molecule, and you need to check that whether that molecule can be like drug-like property or not. In that case, we can calculate some of the chemical reactivity parameters, and you can correlate with that. So what is, you can calculate HOMO energy and LUMO energy. From there you can calculate the band gap, and then you can calculate their softness, ionization potential, electronegativity. From there you can connect. And even let's consider, by performing the DFT calculation, you can predict that, so which part of your ligand will interact with your protein. Let's consider you did the molecular docking. So only specific functional group which are present in your ligand, it is forming some kind of interaction with the amino acids which are present in the protein. So now performing the DFT calculation, you can tell that why it is forming the interaction only at that position, why not other position. In like that, you can correlate in your life science from medical field. But if you want to study specifically the protein structures or enzyme structure, in that case, you need to perform the MD simulation, molecular dynamic simulation, where we are going to use the molecular mechanics. I hope it is clear to you, Sarika. And there is one more question. Why functionals are needed? So why not just functions? So can you please explain? Yes. So what I said, so functional means it is a function of functions, right? So we are going to consider density as a functional, and it is like we are going to focus on the space and time. So because if you remember the Heisenberg uncertainty principle, what does it tell? So it is impossible to determine the exact position and momentum of the microparticle, okay, simultaneously and accurately. Either at the same time, either you can predict the momentum or you can predict the time, speed. Momentum and speed are both are same, like position. Either you can their speed or you can predict the position, but you can't predict both simultaneously. In that case, if you use the individual function, either if you use this function of momentum or you can use the function of time, you can predict only one property. But here we are considering the overall electron density of the system. That's why we need to calculate both momentum and their position. So that's why we are going to consider the functional. I hope it is clear to you. VS Gayatri. And there is one more question, like what is the best software for the computational studies for the biological molecules? See, there are multiple softwares are there. It depends on the what kind of studies you want to do. Okay. If you particularly tell that what studies you want to do, then I can tell that which software is better for those studies. Okay. Suhaib. And there is one more question, how DFT use it for mechanical studies? In DFT, like see, you can calculate how the stress and strain will affect the properties of your material, right? So mechanical property, let's consider your material, you're going to study some kind of like properties. And now you can study that when you apply some kind of stress, if you're going to apply some pressure, or if you're going to apply some kind of strain to your material, in that case, how the properties of that material is changing. Okay, you can study, those are comes under the mechanical study. Mazid, I hope it is clear to you. And one more question, how it is explain the electron charge transfer in heterojunction catalyst system. So here what we need to do, in case of heterojunction, you need to build your model. Let's consider you are going to do the heterojunction of like graphene and molybdenum disulfide. Okay, let's consider 2 layer, otherwise let's consider 3 layer. First layer is graphene, second layer is like molybdenum disulfide, and the third layer is the hexagonal boron nitride. You have this is a heterojunction. In that case, what you need to do, you have to build your slab model for the graphene separately, slab model for your molybdenum disulfide separately, and slab model for the boron nitride separately. And now you need to perform the optimization. Here you are going to find out what is the energy, and you have to find out what is the charge, all those kind of things. Then similarly, how to build your composite model, heterojunction model. All the three in one slab model only, like graphene, then keep your molybdenum disulfide, then keep the boron nitride. And now you just study all the DFT calculation, like energy, optimization, DOS, and density of state. From there, you can easily find out how the electronic transition is going on. For example, if electrons are moving from, let's consider heterojunction, let's consider you are going to study the corrosion studies. Okay, so you took some iron. Corrosion means, let's consider any kind of steel. Let's consider iron layer, and you have synthesized or like invited on material, so which can inhibit the corrosion. So now you need to make the heterojunction of your iron layer and the material you have synthesized. Let's consider like some carbon dots, nanotubes dot, like carbon nanodots. And now what you need to do, heterojunction, let's consider if the electrons are moving from your carbon nanodots to the iron, it indicates that, so it is a best corrosion inhibitor. So it will form the protective layer around your iron. So based on that, you have to compare. So it will give some values. Based on that value, you have to correlate with your experimental data. I hope it is clear to you, Rakesh. And okay, so whatever the question you have, you just write it in the chat box. I will just take like 5 to 10 minutes to answer this question. Then I will continue the session. So there is one more question. So let it be molecular docking and ab initio modeling, sir. So for molecular docking, there are a wide variety of softwares there. If you want the free softwares, so in that case, I will suggest you to use Autodock or Autodock Vina. And you can perform that calculation either by using the Pyrex or by using the Chimera. For ab initio modeling, like just if you want to do normal studies, then you can go, best option is the for MD simulation, ab initio modeling. In that case, the best one is the Grumax. Either you can go with a Grumax or you can go with the Desmond, or there's a LAMPS is also there, games also there. But I will suggest Grumax is the best one. And there is next question, can we predict the stable composition based on the constituent atom? Yes, we can predict. We can predict. So let's consider stable composition is what? You can just add, like, for example, you are going to prepare one alloy. You are going to mix like different composition material. And among that, if you have to find out that, so which composition will give the best stable structure? Very simple. You just do the different types of composition. You just prepare your structure and do the optimization. So which one will give the lowest energy? That is the most stable one. Bhargav, I think it is clear. There is one more question. What is the purpose of DFT studies in metal complex? See, in metal complex, it depends on that. It does not depends on like what kind of material, whether it is like metal complex, whether it is like organic material, inorganic material, solid metal insulator, not like that. It depends on the what kind of application you want to study. Marutavani, okay. It depends on like application. So what application you are going to focus. Otherwise, if you are not going to focus any application, if you want to just study perform the DFT calculation, by performing the DFT calculation, you can find out that, so what is the stable conformation of your complex? What is the total energy of your complex? What is the charge? What is the dipole moment? What is the vectors? What is the charge at each atom? Okay. And you can predict the theoretical IR spectra, UV spectra, NMR spectra. You can do all the theoretical calculation. And you can supplement your experimental data if you don't want to focus any application. I hope it is clear to you. There is one more question. I am a biotech student currently. I am doing my Ph.D. in electrochemical sensors. Okay. Can you please tell me what way I can apply this DFT in my research? Currently, now I am using nanomaterials like metal oxides or perovskites for sensing of drugs, pesticides, and water pollutants. It is very simple. You can just consider your main focus is electrochemical sensing, right? Now you are going to develop some sensing materials, so which can sense. Okay, especially you are going to focus on metal oxides or perovskite material. And for application is sensing of your drug molecules or pesticides or pollutants which are present in like water pollutants, let's consider. In that case, what you need to do, you can, by performing the DFT calculation, you can study that whatever the material you have designed, either your metal oxides or like perovskites, you can study that whether it is and you want to you have taken some chosen some kind of pesticides or some water pollutant like cyanide or arsenic which are present in the water or any kind of things. And you can find out whether whatever the material you have designed, whether it can sense it or not, whether that material can absorb it or not. If it will absorb, what is the absorption energy? So what is the absorption site? You can explain the whole phenomena theoretically. So experimentally, whatever the things you are going to explain, you can supplement the whole thing with the theoretical studies. I hope it is clear to you, Muhammad Basha. Let me check. There are some questions. Let me answer this question. So which software is used to study the effect of radiations or temperature on proteins? So effect of radiations or temperatures on protein, for that, you can perform the MD simulation calculation. to study the effect of temperature or pressure or radiation, you can go with the MD simulation, and you can increase the temperature, like a lower temperature, higher temperature, you can perform the MD simulation. There you can study how the stability of your protein structure is changing. You can study. For that, you can go with the MD simulation, either by using the Grumax or a Desmond or LAMPS, anything is fine. Sir, can we make 2 electrode battery system using the 2 different materials and to do the simulation? Battery system using the 2 different materials. Yes, you can do that one, but for that one, we are going to do the molecular mechanics, quantum mechanics, this kind of Jessil. Okay, I'm answering to Jessil's question. So he was asking that. So we can make, like, can we make this 2 electrode battery system using the 2 different materials and to do the simulation? Yes, but the thing is that you can do that one, but for that, these quantum mechanics are like DFT is not that much. For that, we have to use the molecular mechanics, and there we have to perform the kind of like simulation studies for that. But we can do that. And there is one question from Sachin Kumar: how DFT analysis is applicable in the medicinal chemistry, and how it can be correlated with the biological activity of the molecule? Yes, so you can do that one. See here, let's consider you have synthesized the series of molecules. For the biological, let's consider. So you have synthesized like a series library of molecules. Let's consider you have synthesized 20 molecules. And for 20 molecules, you have determined their anti-cancer activity. So here you can perform the DFT calculation. By performing the DFT calculation, you can calculate the various chemical reactivity parameters. So chemical reactivity parameters means homo energy, LUMO energy, band gap, their ionization energy, electron affinity, chemical hardness, chemical softness. So based on those properties, there you will get some values, numerical values. So based on that numerical values, you can just correlate that. So how the interaction between your ligand molecule and the protein is taking place. Let's consider you will do that molecular docking, and there will be some kind of interaction between your ligand molecule and the protein. And now you can explain that why there is a hydrogen bond interaction. So why there is some kind of like non-covalent interaction, like van der Waals interactions. Why there is a pi-pi stacking? Why exactly there it is binding? So you can easily correlate all those kind of things. I hope it is clear to you, Sachin Kumar. One more question from the Bhargav. Can we predict the stable composition for all inorganic and organic items, or only inorganic? For all organic, inorganic, everything you can find out. Even for the solid materials, 2D materials, for all materials, you can find out the stable composition. There is one question from Suhaib. So why particularly Gaussian package for quantum mechanics? What about the other, like Gaussian software for your kind information? We are also developing electrochemical biosensors or gas sensors. See, there are multiple softwares are there, okay? I won't suggest any particular software. There are multiple software, like Gaussian is there, Orca is there, Quantum Expressor is there, Burai is there, WASP is there, Schrodinger is there. It is up to you. So you can use any kind of software, okay? By using the, even if you want to perform like quantum mechanical related calculation, you can go with the COMSOL multiphysics also, okay? But COMSOL multiphysics is like if you want more advanced like studies related to battery, material science related, in that case, this COMSOL is more preferable. If your work is more related to these organic molecules or inorganic molecules, in that case, Gaussian I will preferable. Okay. And because Gaussian is very user-friendly, automatic, you just need to give some clicks. You just prepare your structure and give some clicks and submit the calculation. And you can perform the same calculation by using the quantum mechanics also, Burai also, but the thing is that they have to use some kind of commands. So those are like Linux-based softwares. And COMSOL is also a commercial software. If you have the license for that, you can use that one also. No problem. And for electrochemical biosensors and gas sensors, I will suggest to you use either Quantum Expresso or Burai. That is a free software, and that is one of the best one for those kind of studies. Or you can, if you have the WASP license, then you can use the WASP also. Okay. Any other questions? So if you have any questions, please write. So there is one more question. So please share some research paper based on this so that we can relate to our study. Definitely I will share. So any other questions? So if you have any questions, please write. Okay, I think there are no questions. Okay, let's move on to the next part. So if you have any questions, you just write it in the chat box. I will take at the end of the session. Okay, so now I am going to demonstrate you how to download and install the software. So for this workshop, we are going to use the Gaussian software. Now I'm going to demonstrate you. So first you need to download the software. So already, I hope all of you already downloaded the software. I have shared the link to you, but those who not yet downloaded, so just follow the step. Now I will go a little slowly because the installation you have to do simultaneously with me. Okay. And I will suggest you that whenever you are going to join the session, better you just join the session through your smartphone, and you can do the whatever the calculation I will demonstrate you just do simultaneously with me in your computer or laptop. So you can follow each step and you can do simultaneously with me. Okay. So to install the software, first you need to download the software. To download the software, you just open your WhatsApp and you just navigate to the group, this adsorption and sensing studies. And here you will find one link here. Sorry, not this one, this one. Okay. Gaussian workshop. You just go to this Gaussian workshop. So here you will find one link here. Let me see. Yeah, this Gaussian DFT workshop. Yeah, this one. You just click on this link. Okay. So once you click on this link, it will be redirected to the Drive account. So this here, it will be redirected to this one. So you can just directly click on the download. But some of the participants, they are not able to download it because if you open it in the mobile, you can't download it. Open it in your laptop or computer. And if you're not able to see this kind of icon, then usually it will show this kind of like 3 dots at the right top corner of your screen. You just click on these 3 dots and you just click on the download also. Here it is showing, so I no need to click here. Otherwise, here I can click directly on this download button. Okay, so I'll just click on this download button here. Okay, once I click on download, it will show directed to this page. So it will ask here, you just click on the download anyway. And the size of the software is around like 524 MB. So it will take some time to download depending on your internet speed. So let me click here and download anyway. So once I click on this download anyway, so it will start downloading. See, the downloading got started. So it will take some time to download. Let me wait until I download the software. Yes, it got downloaded now. So I'll just close the window. I don't have any work with, I will close. So like that, you need to download the software. So that is the first step. I hope all of you downloaded. Okay. So before going ahead to the installation part, can you confirm me that how many of you downloaded the software successfully? So those who have downloaded, type Y in the chat box. So I will get some idea how many of you downloaded. So if anybody facing the problem also, you have to write that what kind of problem you're facing so that I can provide the solution for that. Yeah, nice. So most of the participants, I think almost all they got downloaded. Okay, fine. So once you have downloaded the software, you will get this kind of folder. Let me in my download folders. Yeah, you will get this kind of folder. So let me copy it and I will keep it on desktop. Yes. So once you have downloaded the folder, you will get this kind of folder. So this like you have to unzip this folder. So to unzip that folder, select that folder, right click on your mouse and click on the extract all. And you just click on the extract button. So it will extract the folder. Okay. So let me close this one. So once you extract that one, so we'll get it will create one more same folder, a folder with the same name. Okay. So now to install the software, you just open this folder, double click. So there is one more folder with the same name like Gaussian. Again, double click here. So here you have the 2 folders. So one is the Gaussian, another one is the Gauss wave. So to perform the DFT calculation by using the Gaussian software, we need to install the two software. So one is the Gaussian and the second one is the GaussView. So Gaussian is the main software to perform the calculation. GaussView is the GUI for the Gaussian, like it is like graphical user interface. So because let's consider if you want to build your structure, if you want to model your structure, and if you want to create the input file for the calculation, in that case, we are going to use the Gauss view to visualize the optimized structure, like different graphs. For that, we are going to use the Gauss view. Gaussian, we are going to use the perform the calculation, different types of calculation. And now we are going to install the Gaussian 9. Okay, so version 9, ninth version we are going to install. To install the software, so you just open the first one. So while you're installing, you have to keep it in your mind that sometime if you install Gaussian first, you will get some kind of error while performing the calculation. So to avoid such kind of calculation, first install the GaussView software, then install the Gaussian software. Okay, I hope it is clear to you. So now I am going to demonstrate you how to install the GaussView software. So do simultaneously with me and follow each step. And if you're facing any kind of technical issues, please write it in the chat box. So because this software is needed for the further training. Okay, so to install the GaussView, this is the one second folder. You just double click on this folder, open this folder. So once you open this folder, there are two files are there. The first one is the GaussView 6.0.16 Windows 64 version. So this is the main software. So below that, there is a one test document is there. So it is a test file which contains the serial number to activate your software. Okay, so to install the software, you just double click on this one, GaussView. You just double click. So once you double click, it will start the installation. Okay, so you will get this kind of window. It will start the installation. So here something is showing for me. The installation cannot proceed because the SGJ job manager is running currently. Let me restart my system here. I think here I need to restart my system. Just what I will do here. Yeah, if I restart again, the recordings will go. Yeah, let me clear the history here. So because some function is going on, I need to close this one. Something it is showing that some ST job man GUI is going on. So is anybody facing the same problem? Okay, okay. So just let me clear my user because already I have the Gaussian software, but just to show you, I have just uninstalled it. Maybe I need to check that is there any, yeah, I think SD job MU is going on. Let me delete this one. So actually I need to delete this one. Are these files? Let me delete this. Yes, yes. I think because that is working, I need to close this one. Let me go with the task manager here. Otherwise, I need to restart my computer or I need to close that one. That is, yes, this one. Yeah, let me close this SCJ. Yes. Now let me try now. Let me, for safer side, I will just delete all the files which are related to my previous software so that I can do it now. Yes, perfect. Okay, so now to install the software, you just open the folder. Let me, okay, Gaussian, go to the Gauss view and you just double click on this now, double click. Once you double click here, it will start the installation. Okay, so you will get this kind of window. And after that, after like 10 to 15 seconds, you will get this window. Okay, so here you just click on the next button. I hope you are doing simultaneously with me. Okay, so you will get this kind of window here. So you just click on the next button. So once you click on the next button, you will be redirected to this page. Okay, if you want, you can just read these terms and conditions. Otherwise, you just click on the next button and see here. Now it will ask you your name, your company, and serial number. It is up to you. This is optional, name and company. If you want, you can give your name and your institute name. Otherwise, you can just skip it. But this is very important. You have to provide the serial number here. Okay, for serial number, you just come back to that folder. Same folder, there is one more file with the name like serial. You just click here. So once you click, you will get this serial code. You just copy this one, Control C, and just minimize this one. Come back to your software window and you just paste it here. Control V. Okay, and click on the next button. Click on the next button. So once you click on the next button, see, you will get this kind of window. Serial number validated. Click on the OK button. So once you click on the OK button, so it will ask you to provide the destination for your folder. So it will show that where it was going to install. In my case, it was going to install in the C drive, and it was creating the new folder with the name G16W. Okay. So like that, if you want to change, you just click on the browse and you can change the location of your software. But I don't want to change. I will go with the default option and I just click on the next button. So once you click on the next button, it will show like whether you want to create this desktop window, all those kind of things. Okay. You just click on the next button and now you just select all the file format. So it will ask you that. So what kind of input file or output file you want to open by using the Gaussian software. So I will suggest you to select all the type. Okay, all type, you just check all the boxes here. Okay, select everything and just click on the next button. And again, there are some more file formats are there. You just select. Let's consider if you install the software without selecting this .mol, .stf, .rnx, if you open the file which are in this kind of format, your software won't support. So that's why better you just select everything. Okay, again, click on the install button. So once you click on the install button, the installation process will start. It will take around like 30 to 40 seconds to complete the process. See, the installation was done. You just click on the finish button. Click on the finish button. So once you have done the installation, see, it will create this icon on your desktop. So this is the Gauss view. So this completes the installation of Gauss view. Now we are going to install the Gaussian software. But before going to demonstrate you how to install the Gaussian, so just let me confirm it. How many of you installed the Gaussian software successfully? So those who have done, you just type Y or D in the chat box. If anybody facing the problem, you just write what the problem you're going to face. What are the problem you're going to face? Yeah, perfect. Okay, so almost all install the software. Okay, fine. So now let's try to install the Gaussian. Okay. So just follow the steps now. Now focus here. So to install the Gaussian software now, again, you just open this folder. Let me close this one. Okay, open this folder. Even I will just close this serial file also. Okay, open this Gaussian folder. And again, double click here. Now click on this one, Gaussian. So we are done with the Gauss view. So now we have to install the Gaussian. So to install this one, you just double click on this folder. So here also you have the two files. One is like setup in the application type. This is the main software. And one more is like test document with the name serial. So this contain the activation code. So to install the software, you just double click on this setup. Double click here. So once you double click here, it will start the installation process. So let me minimize this one. Yeah, so installation will start. Okay, so you will get this kind of window here. You just click on the next button. nest. Now here it will ask the serial number. Again, you just come back to the folder and open this test document with the name serial. Open it and copy this one. Copy this code, Control-C, and just minimize this word, and you just come back to your software installation. Yes. And here, just paste it here. And here also, this one is like optional. If you want to give your name and company name, you just give it, otherwise just skip it, okay? And you just click on the next button. So once you click on the next button, here also will get this kind of message like serial number got validated, and you just click on the OK button. And now here it will give some information. No need to worry about that. You just click on the next button. Again, it will show like where it is going to install the software. Okay. So this is the destination of your software installation. If you want to change, you can just click on the browse button. I don't want to change. I will go with the default option. I'll just click on the next button here. And now just click on the install. The installation will start. So it will take around 40 seconds to 60 seconds to complete the process. So we'll wait until it completes the process. I hope all of you are doing simultaneously with me. If you're facing any kind of technical issues, please write it in the chat box. Otherwise, take the screenshot of the error and you just upload it here so I can get to know what kind of error you're going to face. So here we need to create one Scratch directory. It will ask you to create the Scratch directory. So Scratch directory means whatever the calculation you will done, it will go and save in that folder. If you want to make a folder, you can just create a folder, choose where you want to create, and you can make a new folder. Otherwise, you just click on the OK button. Automatically, it will create the Scratch, this one. Let me just click on the OK. So here it will ask that the Scratch directory will be saved in C directory, and this Gaussian 09 Windows version and Scratch. In that folder, it will create the Scratch. You just click on the OK button and you just click on the Finish button. So it will complete the installation of Gaussian. Okay. So we are done with the installation of GaussView and Gaussian software. I hope all of you done with me. So please confirm me that how many of you completed both the installation of both GaussView and Gaussian. So write it in the chat box. Okay, so most of are done. Is anybody facing the problem? If you're facing any problem, you just write it in the chat box. Okay, I think there are no technical issues. All of you, I think, installed the software successfully. Okay, fine. Okay, chalo, then we'll start the next topic. Let me, okay. So now we'll discuss about the basic usage of the software. Okay, so now we are done with the basic concepts of DFT. We are done with the download and installation of the software. Now we'll learn how to use that software, the basic usage of the software. So just let me stop sharing. Let me share it once again. So can anyone confirm me that whether are you able to see my screen or not? Okay, perfect. Okay, so now open the software. So see, there are two icons there. Once you are done with the installation of GaussView and Gaussian, you will get these two icons here. Okay, so this is for the GaussView and this indicates the Gaussian. Okay, so once you open the GaussView software, whenever you are going to open the software, so you have to double click on this icon, GaussView icon. Once you double click here, automatically it will open both your GaussView software and Gaussian software. Okay, otherwise, if you want to run the calculation directly by using the Gaussian, if you have the input file, then you can use this one. I will show both also. First, you need to learn GaussView. Then I will show how you can directly run the calculation without using the GaussView also. I will show, but for that, you have to work little manually, like you have to create the input file, all those kind of things. So there is a question, once we install in C drive, we can save in any drive further. Yes, we can save it. So whatever your job is there, when you are going to submit the job, you just create the folder, like where you want to save your output file. You can save it on the desktop, any other folders like D drive, E drive. It is up to you. You can change that. Okay. So now all of you open the software. So to open the software, so you just double click on this icon with the GaussView, double click. So once you double click, okay, the software will open. Okay, so here, when you open your Gaussian software, two windows will open. Okay, so like this. So there are two windows are there. So let me arrange it properly. I will just, yes. So like this, you will get these two windows. One is like a gray color window. Another one is the blue color window. So among these two windows, one window is the Gauss view window. Another one is a Gaussian window. Okay, so this one at the top, you can see it here, the gray color one. So this is the Gauss view window. That is a main window. So you can just prepare your input file. You can draw your structure. You can visualize, do the analysis of your result, all those kind of things. And this is the your Gaussian window. Gaussian means you cannot say that it is a Gaussian window. So it is like main visualization window, and it is connected to the Gaussian. Okay, so it is like main, whatever the structure you can do here, changes, it will appear here. Okay, so this is the main primary window, and this is a secondary window. And already I told that Gauss view software is used to draw the structure of your molecule. So which can be given as the input file for your Gaussian software to perform the different types of DFT calculation. So there is one question. Some of the participants are facing problem too while opening the software. Just let me open what is that screenshot. See, already I told that. So whenever you are going to install the software, so you have to create one scratch file. Okay. I think in your case, that scratch file is not created. Okay. Samruddhi, in your case, the scratch folder was not created during the installation part. So please, you just do uninstall the software and you just install it once again. Okay. That is the only problem. See, because there is one temporary directory is not there. You just do that one. No need to worry about that. And after that also, if you're facing the problem, you just get back to me. Okay. Okay, see here. So now I will just explain the, let me. Just close this one, everything, all the windows. Let me close everything. Yes. Okay. So now let's try to understand different menus or different tools which are present in the software before going to the calculation. Okay. So first I will talk about this one. So at the top, you will get the name of your software, the what kind of version you are going to use, all those kind of things. Below that, like how you have the menu bar in all the softwares. So here also you have the menu bar, and there are different types of menus are there, like file menu is there, edit menu is there. So by using the file menu, like if you want to open the structure, if you want to upload some structure, you can use this file menu. And if you want to create some new page, this one, you can use this here. And if you want to save your file, save your calculation, if you want to print, if you want to save the images, and if you want to do overall settings in your system, in that case, you can use the file menu. Okay. And next one is the edit menu. So you can use the edit menu to edit the structure. Later, I will show how to use it. In the tools menu, also you have different tools are there to draw the structure you are like to perform the various kind of calculation. And the main menu is the builder menu. So this is the most important menu in the software. So by using this menu, builder menu, you can build your structure. You can do the different kind of changes to your structure. I will explain how to do that one. And the next one is the view menu. So here, like you can just change the view of your software also, and view of your structure also, like how you want to show, like whether you want to show the symbols, bond, everything is there. Later you will understand how to use all the options. And this is one more important menu. So once your input file is ready to perform the calculation, we are going to submit the calculation, we are going to use this calculate menu. Okay. And the next one is the result menu. Once the calculation was done, to analyze your output data, we are going to use the result tab or result menu. And next one is like Windows, there are some extra options are there. And this like help button, some of the information related to your software, you can find it in help menu. Okay. So later I will explain each of all those kind of things. And below that, you have like many tools. So these are like shortcut tools. Okay. So these, all the tools, there is nothing special in these tools. So whatever the things we can do by using these menus, we can do it by using these tools. So they have given the shortcut directly instead of going to this folder, like this menu and opening. So directly you can use it here. Okay. Now let's try to understand what is the role of each menu. So for what purpose we are going to use. So first, this one is very important. So these are the tools which are present in your builder menu. See, let me open here. See, what are the tools are there here? The same thing is present here as a shortcut. Okay. So here, see here, there are some buttons are there. These are the very important buttons. So the first one is the element tab. Okay. This is known as the element fragment button. If you click the cursor on that icon, it will give the name of that button. So it is the element fragment button. So by using this element fragment button, for example, let's consider if you want to draw the structure of like aliphatic structures or acyclic structure, okay, or if you want to use a periodic table, you can use this tab. See, if you double click here, it will open the periodic table. And here you can select the different types of element, what kind of fragmentation, like bonding you want to show. See, you can do it here by using the element fragment button. So later I will show you how to draw the structure by using fragment button. Let me go with I will just choose the carbon here. Perfect. Okay. And the next button is known as the ring fragment button. So this one is a ring fragment button. So this is to draw this aliphatic like acyclic structure or periodic if you want to use some specific element. And by using this ring fragment button, you can draw the aromatic structure. If you want to like, if you click here, double click here, so you will get this window. So there are some already like preset rings are there. So by using these rings, you can draw the aromatic compounds, aromatic structures. Okay. So let me close this one. And the next one, you have the R group fragment button. So R group means it contains the different functional groups. Double click here. So see here, if you single click here, it will choose only one functional group. Okay, if you choose here, only automatically it will choose the one ring. Let's consider once you have selected here, I will show this option later. And okay, if you double, see automatically it was selected the formyl group. Okay, otherwise if you double click here, you will get the different types of functional groups here. You can directly choose it and you can attach to your structure. Okay, and the next button is the biofragmentation button. So this one, biological fragmentation button. If you double click here, see here there are different types of biomolecules are there. So like amino acids are there, nucleosides are there, and other biological is there. So you can choose here. It consider there's amino acids. And if you click here, there is a list of all the 20 amino acids are there. And you can choose automatically, it will show the structure of here. Like, let me consider here, let's choose the lysines here. So automatically it will show the structure of lysines here. Okay. And like where you want to, like central fragment or amino acid terminal fragments or carboxylic terminal fragments, you can choose it here. Especially if you want to do the study the DFT calculations of biomolecules, you can use this option, this biological fragment button. And the next one is the, this one is known as the custom fragment button. If you double click here, there is a custom. Here, if you want, you can add some kind of structure and you can save it for your further work. Okay. I don't want to do. So very simple. Like consider you have some structure, ready-made structures. If you are going to use it like time by time, and you just draw the structures and save it here, upload, just click here and you can just upload those structures and you can use it for your future work also by using that custom fragments. And see here, there is one search button is there. It is very simple. It consider if I click here, if I select here, so without opening here, you can just click here. It will give the list, benzene biphenyl. So benzene biphenyl. So the second one is naphthalene. Fourth one is the anthracene. Okay, phenanthracene, pyrene. So like that, it will give the list. Either you can open from here, automatically you can select from here also, biphenyl. See, automatically it will select the biphenyl here. Similarly, if you go with this here, if you select the carbon, it will show what kind of carbon, like single carbon atom, like carbon divalent, like then here like carbon trivalent, tetravalent, like tetrahedral, like what kind of carbon you want, you can choose it here. Depending on like type of element. If you go with the beryllium here, so it will show like what kind of beryllium bonding atom you want. Okay, like beryllium terminal or linear structure, you can choose that one also. Yeah, so first you have to understand everything properly, so then we can use it. It will be easier for to use which option is like that. So if you want to give like specific name, you can call it as a selection fragmentation button, select fragmentation button. And here there are some keys are there here. And this one is the, you can call it as like a bond option, like bond tab. So by using that, you can modify the bond. Let's consider if you want to change from single bond to double bond, or double bond to triple bond, like covalent bond to the coordination bond or hydrogen bond, In that case, you can use this option. Okay, you can use this tab. Now just to see the understand what is their role. Later I will explain you how you can use that tab also. I will explain after this explanation. I will show you how to draw the structures by using this one. That time I will explain you. And this one is the angle tab. You can call it as angle tab. So by using this tab, see, by using this one, you can just change the bond also. Even you can measure the bond length also. Okay, you can measure the bond length also. By using this one, you can change the angle in your structure, bond angle also, and you can measure the bond angle between the like different atoms. And this one is the dihedral tab. So by using this tab, you can find out what is the dihedral angle. Then you can change the dihedral angle. You can rotate your dihedral bond in your structure. And this tab is known as the inquiry tab. So if you have like any information of that bond, you can use this tab also. And this tab is known as the valence tab. Okay, add valence tab. Because for example, if you want to add the valency, let's consider you have drawn only like benzene ring, just you have shown the carbon. You did not represent any kind of hydrogen which are attached to the carbon. And if you want to represent them, you just click on this button, automatically it will add the hydrogen and it will satisfy the valency of that structure. And this one is the known as the like delete atom. Okay, this one is known as the delete atom. If you want to delete some specific atom of your structure, you can select this button and you can delete the atoms. And the next option is the invert atom. So if you want to do the invert, okay, in that case, you can use this button. And these are like not that much important. These are known as like a clicking button. These are the like marquee button and these are the brush button. So these three buttons are used to select the structure or different atoms which are present in your structure. Like this is like particular like clicking. If you select this one, you can choose the individual atom. So this one is marquee, means just by clicking the rectangle, you can select the overall structure. And this is like you want to select only some part of that, you can use this one. And here there are two options are there. This one is the deselect all the atoms. If you want to deselect all the atoms, you can just click here. If you want to select all the atoms of your structure, you can just click on this button. Okay. So other than that, there are some other options are there here. So these are like, one is like add view. Like add view, you can call it as like a molecule group. You can use this button. I'll show you later how to use this add view like this. It will give more. Like however, this window is there. If you want more windows like this, you just click here. So either click this one also. There is one more plus button is also there. You can click here also. Okay, so here it will give this one. Let me click here. Let me open it. Okay, so here like add view, and this one is like is known as like center button. Like for example, your structure is present here. If you want to keep exactly at the center of this screen, you just click on this button. Automatically, it will bring your structure to the center of the screen. And this button, I think you can use it for to display the different types of format. Okay, so like that, if you want to see only this window, you just click here. Then it will show only this window. Like display, these are not that much useful. Like you can use these things here. And another like this, like to view the different files. If you want to edit the files or if you want to view the files, you can use this button. Or you can just to stream your output file, you can use this button. I hope it is clear to you what is the role of the each different tools which are present in this row. Okay. Similarly, let's come to here also. Let's try to understand the other here, like here. The first one is like create a new molecular group. If you click here, it will give new molecular group. Let's consider if you want one more here, and if you click on this link, it will create the new window here. You can create the multiple windows by using this tab. And by using this like plus tab, already I told that is like to add the molecular group. You can use this one. And like this is like open file. If you want to open the file directly, some structures are like output file, instead of going to the file and going to the open, so directly you can click here. So these are like shortcuts only. So I'm, instead of explaining each folder like menu separately, I'm explaining the tools which are present here only. And now it is like you already know these things, right? If you want to save your calculation or structure, you just click on the save button. And this is like print button. I don't want to talk about much about these things. And next one is the like save image. Whatever the image here it is there, if you want to save, you just click on this button. And like whatever the calculation you have done, if you want to make it as a movie, animated movie, like short movie, and you just click on this button. So it will make your calculation as a movie. Okay. And here, if you come here, there are some tools are there. The first one is like cut tool. These are like copy, paste. This is the copy tool, the paste tool. This is the delete option. This is the undo button, redo button. These are common things. So that's why I'm just telling, not going to explain much about those things. And this is like rebond. And like if you want to clean your structure, once you have drawn the structure, you have to clean your structure. In that case, you can use the clean button, that brush icon. And this is like, this button is to standardize your Z axis. And like if you want to symmetrize your structure properly, if you want to orient in a symmetrical orientation, you can click on this button. Okay. So other than that, there are some buttons are there like this atom list. If you click here, it will give the list of all the atoms which are present in your structure. And this R button is known as the like reductant coordination editor. So this tool we are going to use when you are going to perform some kind of like calculation, like especially like a scanning, PES calculation, scan calculation. In that case, we have to change the coordinates. We have to specify the coordinates. In that case, we are going to use this tab. And the next button is here. This is known as the link button. You can link the different connection editors or file to file later. And this is one is the layer selection. So different types of layer you can do the like heterojunction structure. You can select the different types of layer selection. And this is like PBC editor, like periodic boundary condition editors. Let me. Okay, Samruddhi, no problem. I will just after this session, I will get back to you. Okay. You just listen the session. So after this session, I will get back to you. Okay. So here, the next I'm talking about this one, right? So this is like periodic boundary condition to change any periodic boundary condition, especially when you are going to do some metal oxides or solid materials, then we are going to use this layers button periodic boundary condition. And this is known as the MO button, like molecular orbitals. If you want to visualize the homo-LUMO orbitals, you can just use this button. So now these buttons are deactivated. Whenever it comes, when you open your calculation, then it will be automatically, it will be activated. Okay. And other than that, what I need to, we are done with this option. We are done with this. And let me, yeah. So let's come back to here. So this button, this is like, it will like current job. If you click here, so it will show us that what are the current jobs are going on. Is there any calculation is going on? Okay. And if you want to manage your calculation, you can click here. This is a job manager button. So other than that, there are some, these are some window tabs are there. Like if you want to see as a cascade view, this is like, if you want to see as a tiles view, and it is like previous option and it is like next option, you can just go with like this. And apart from that, if you go with here, you can choose your scheme, like what kind of scheme you want, like different schemes are there. You can just choose here by using these options. And here you can just give the list also, like different types of scheme list also there. Like these are the different methods they have given for the calculation here. So, but I will go with the default scheme is preferable here. And other than that, here what, here also the schemes are there. Here also schemes you can choose here. Same option here. So there are some things are there like artifact and DFT calculation. So here these two button like to calculation, to quick launch something, you can just do all those kind of things. These are like not that much important here. And here it will give the structure of your like name of your structure, whatever the structure you have here, it will give you the structure name here. Okay. So this is the overall introduction about your main software, and whatever the structure you will draw here, it will be shown here. So do you have any questions so far? Okay, now I'm going to show you, demonstrate you how exactly you can draw the structure, build the model, all those kind of things. So before that, if you have any questions, please write it in the chat box. So if there are no questions, if everything is clear, then type Y in the chat box. So then I will get to know whether you are following me or not. Perfect, perfect. Okay. Okay, so now just come back to drawing the structure. So before drawing the structure, now let me show one thing. Let's consider, I will just go to the, let me go to the builder, and otherwise go to the view. and you just click on the builder button. Once you click on the builder button, this window will pop up here. Go to the view. I'm repeating once again. Go to the view. Either you can use directly from here, or you can open this one also. You just click on the view button, just select this builder button, and this builder screen will be activated here. So by using this one, you can easily draw your structure. So before drawing structure, let me see here. So already there is a carbon tetrachloride is there here. Sorry, carbon tetrahedral. This, I think these are hydrogens. CH4, methane. This is like methane. Okay, CH4. Like if you want to see here, your structure I have selected. Before that, you have to understand how to use your mouse here. So by pressing the left button of your mouse, you can rotate the molecule. If you want to rotate the molecule, all the direction. So let me draw the same structure. Let's consider here I have selected the methane. And if I want to draw this structure here, you just keep the cursor on this window and press the left key of your mouse. Just click here. So automatically the structure will come here. See, in the both the screen, even in the this screen or this screen, if you want to rotate your structure in all the X, Y, Z direction, okay, you just press your left key of your mouse and just drag it. Okay, and you can rotate the structure according to your wish. That is the first thing you have to remember. And the second thing is, you can zoom in or zoom out your molecule by pressing the right button of your mouse. See, you just press the right key of your mouse and you just see, just drag it. There you can zoom in or zoom out. Just press your right button and hold it and drag your mouse. So you can zoom in or zoom out. The same thing you can do it in your this screen also. I hope you are able to see the difference. Okay. And now let's consider if you want to move the structure from like one place to another place. So this is the overall window. If you want to like, if you want to move this whole structure from this position to this position here to here, in that case, you just do one thing. You just press the roller button of your mouse, the center button of your mouse. Just press it, hold it, and just drag your mouse. So wherever you want to move, can just move the structure from one position to another position. In the same window here also, same thing. See, press the center button, that is the roller button of your mouse, and you can move from one position to another position on your screen wherever you want. Let's see, I am moving it here. I have moved here, right? Let's consider, now I want to bring exactly at the center. Now you just click on the center button here. Okay, either you can click here also or you can click here also. Automatically it will bring center. Okay, so because whatever the changes will do, it will be modified here. It will be done by updated here. Okay, and now let's consider if you want to rotate only one molecule. Okay, let's consider what I will do. So there are one methane molecule is there, right? Let me draw one more. I will just keep the cursor here and I will press the left key of mouse. See, there are two molecules. Okay, so there are now two methane molecules are there here. Now see, if I rotate by pressing the left key of my mouse, both the molecules are rotating, right? How to rotate only one molecule? So to rotate only one molecule, press the Alt key of your keyboard, press the Alt button in your keyboard and left key. Okay, see? So what you need to do to rotate only one molecule, particularly let's consider if you want to rotate this molecule, if you don't want to rotate this molecule. Very simple. So press the Alt button in your keyboard, then keep the cursor on the structure, okay? And then press the left button of your mouse, just drag it. See, now you can just rotate it the way you want. We can rotate only one structure. Similarly, if you want to rotate this structure, press the Alt button, keep the cursor on this structure and press the left key of your mouse and you can rotate it. Okay. And to undo and redo, you can use this button, undo, redo. Otherwise, you just press the Control Z in your keyboard. Everything it will do that one. Okay. I hope it is clear to you. In both the window, you have to follow the same procedure. Okay. Now, let me show how to draw the structures. Let's consider if you want to draw the structure of like methanol. So what is the methanol? CH3OH, right? So CH3OH, there is one carbon, 4 hydrogen, 1 oxygen. How to draw the structure of methanol? So first, to draw the methanol, first what I will do, to draw the aromatic, you can use this element fragment button. So double click here. Once you double click here, it will open the periodic table. Select the carbon. Once you select the carbon, So automatically it will select this one as a tetrahedral because the valence of carbon here. So if you want to draw only one individual atom, like let's consider there is a methane molecule. Now, if you want to draw only one like atom, only carbon atom, in that case, you can select only this one. See, now it was showing only carbon atom, nothing else. Okay. So double click here. If you want to show like this kind of things, like there is in carbon, like alkane, alkene, alkyne. If you want to draw the alkyne, you can use this one, alkene. Okay. You know all those kind of things, right? So depending on that, you can choose that one. So usually, normally, we are going to draw the methanol, right? For methanol, I want this one because CH3OH. So among these three, it is this carbon is attached to 3 hydrogen and one it is attached to one OH group. So I will choose this one. Now it was selected the methane, right? So once you have selected the methane, you need to draw the structure here. How to draw once you have selected? You just come to this screen and press the left button of your mouse. So it will add the, so you have to press only once. If you press twice, it will add the 2 molecules of methane. If you press that thrice, it will add the 3 molecule. Okay, just once. Now it is like methane molecule, right? CH4. Now what I need to do, my intention is I need to draw the methanol, that is CH3OH. So now I need to replace one of the hydrogen with hydroxy group, that is OH group. How to do that one? So let me keep it. I will keep this 3 hydrogen. I will replace this hydrogen with the hydroxy group. Again, you just click on this element fragment button, double click. It will open the periodic table now. So now we want to add the hydroxy group, then come to click on the oxygen. Again, it will show how you want to add the oxygen as an atom, or like C double bond O, or like OH. So we want to add like as a OH. So this bond will connect to this carbon and this bond will connect to hydrogen. We need to add the hydroxy group. That's why you just select the oxygen here. Now it got selected here. And now we just come here to this window. Now we have to keep the cursor here and press it. Let's consider if you want to add this hydroxy group to here, you have to keep cursor on this atom. If you want to add it here, you have to keep the cursor on that specific atom. I want to add it here. I will keep the cursor on above this atom and press the left key of your mouse. See, automatically it is added. Now this is the CH3 group and OH, oxygen, and this hydrogen. Let me show it here. I'll just move this one. And automatically see it here. Once you draw the structure, automatically it will calculate here. Total how many atoms are present in your molecule here at the bottom. So total how many electrons are there in your system. So what is the spin of that? Whether it is like singlet or doublet or triplet, it will give it is a singlet. It will also calculate, by default, it will calculate the spin of your system and it will calculate the charge, whether it is positively charged, negatively charged, or neutral. So because these parameters are very important while submitting the calculation. Okay. So in the Gaussian, automatically by default, it will show it here. Whether it is single spin shifted, also it is giving, charge also it is giving here, total number of electrons also information is giving, total number of atoms also giving. So you no need to worry about that. I hope it is clear to you. So like that, you can draw the structure. Okay. So once you draw this structure, let me keep it here. Let's consider it is here. Now I want to bring back to the center. You already know that you just click on this button. It will bring you to the center of this one. And if you want to clean the structure, see, whenever we draw the structure, we won't maintain the proper bond angle, right? Bond length, proper dihedral angle. And without cleaning structure, if you submit the structure direct for the calculation, it will take more time. Okay, it will take more time. That's why before submitting the calculation, you need to optimize, like pre-optimize your structure. You can call it as a pre-optimization, or you can call it as a cleaning up your structure. You have to clean your structure. So once you click the clean your structure, it will arrange your structure. It will modify your structure according to because theoretically in the software they have updated it. Theoretically, the bond length between the OH bond length should be this much. Okay, the CO bond length should be this much. According to that, it will clean up your structure. It is very simple how to clean up your structure. So to clean up your structure, you just click on this brush button. Either you click here or you just click here. Once you click on this brush button, so it will clean up structure. So now you are not able to see that much of difference, right? Because it is already clean. But I will just modify intentionally. Then let me show it here. So there is a question from Girish, how to delete any atom in this molecule structure. Yet I will show now. I will come one by one. Okay. So now, okay, first let me show here. what by intentionally I will add some kind of like so what I will do here, I will add carbon to this one. By intentionally I will add carbon, and let me select this one. So here it is, otherwise control Z. What I will do here, yeah, first I will change, I will for this molecule only I will modify something here. Okay, so before that let me show one by one here. Here let consider if you want to measure the bond length here. Okay, if you want to measure the bond length between these two atoms, you just click here, select this one. So once you select this one, it will be highlighted here. So now to measure the bond length, it is like basic thing, we have to choose any two atoms, right? Minimum, like you just select atom number 1, atom number 2. So see, once you have select two atoms, this window will pop up here. Okay, and it will give the all the thing. Now we can modify the bond length here. Now let's see, even bond type also you can modify. Okay, let's consider if you want to make it as a double bond. Now it is single bond. If you want to make it as a double bond, you select this one. See, now it was changed to double bond. If you want to make it as a triple bond, you just click here. It will change it to the triple bond. So if you want to check it as like this kind of interaction, you can just make it as like, and if you want to make it as like kind of weak bond, you can just click it here. So this is kind of like residual bond. Okay, this kind of bond is known as like, not like resonate bond. Okay, you can call it as a resonate bond. This is like coordinate interactions showing like weak kind of interactions. You can use this bond. And if you don't want to show any kind of bond type, you can just give it here. See, you can just make it, but let me keep it as one only. You can change this one. And like if you want like bond, if you want to like increase the length, now the bond length is like 0.96. See, you can increase. Previously it was 0.96. If you want to increase the bond length between that, see, you can increase the bond length also. If you want to specifically, if you want to keep some bond length exactly that much, you can do that one. Now see, if I change it here, now both this atom also, atom number 1, that is hydrogen, is also moving, and this atom number 2, that is oxygen, is also moving. Both are moving, right? Both are moving away from each other and increasing the bond length. Let's consider you don't want to move the position of this one. You have to keep the position this one as a fixed one. Only you want to change the bond length by changing one specific atom. How to do that? In that case, let's consider if you want to keep it as a constant, you just click here. This is atom number 2. You just click on this down arrow button and you just click on the fixed. Okay, now change. See, now the atom number 2 is not moving. Only atom number 1 is moving, right? So like that you can do. Similarly, if you don't want to change this atom number 1, you want to move only 2. In that case, you just see it here. Let keep it as like translate atom and translate group, and you can just click it here like fixed one. Now see here. I hope it is clear to you. Like that you can modify the bond also. But let me keep it as like this here. Just I will just want to show it here to you. And there are some question here. So if unknown molecule means how we know single or double bond? See, that is very basic question, right? So it is like unknown molecule means how to know single. So without knowing the structure, you can't do the calculation, right? So you just keep in your mind that whenever you are going to perform the DFT calculation or any kind of theoretical calculation, the main source is your structure. Like whenever you are going to perform any kind of experimental data, experimental study, what we need compound, right? You need the compound. Otherwise, you can't do any kind of experimental study. Like that, if you want to perform the theoretical studies, the main thing is you need the structure of that molecule. And that is like very, if you want to find out whether it is a single bond or double bond, means that is like you have to show that we know what is the valency, right? And based on that, if you know the basic chemistry, I don't know if you are from which background. So if you know the basic chemistry, then you can easily find out that. So what is how many bond we have to keep, whether it is a double bond or single bond. Otherwise, we have to keep the lone pair of electrons are charged like that. I hope it is clear to you, Girish. So there is one question from Julia. Okay, changing the bond length means is it becoming the amorphous? No, I did not understand your question, Julie. Like changing the bond length means is becoming amorphous. No, I think how it is changing the amorphous here. So I did not get your question. So please, you just try to ask it in other ways. So because I'm just changing how we can change. Let's consider there is a specific value. Theoretically, we already know that the bond length between like carbon and chlorine, like CCl bond length is this much. OH bond will be this much, like bond length. If it is not there, you can change it according to, you can fix the value. Okay, we are not changing property, just changing. But I'm just showing you how to change. But we no need to change. Automatically, once you perform the optimization, automatically it will calculate and it will give what is the exact bond length of those molecules. And there is a one question from Mazida. We have to draw the spinal oxide using this. Yes, you can draw many kind of structures here. Okay. But when the structure is very complex, I will suggest you to use other tools. There are many free tools are there. So because Gaussian will take more time for the complex structure, but you can draw that one also. So there is one question from like Chandra Prakash. Many times structure overlap has happened. How to overcome the overlap, sir? So structure overlap means like, are you using like multiple structures, or like you're uploading only one structure, then there is a like overlapping in the bond, some bonds are missing or some extra bond is forming, such kind of things. Okay, so here you can change like that. And similarly, by using this bond angle button here. So here it is already 11:35. Okay, single structure. I will explain. No need to worry about that, Chandrasekhar. Yeah, the time is already, okay, we are late by 5 minutes. So can I extend this session for another 10 to 15 minutes? So if you're okay with that, I will extend this session for another 10 to 15 minutes. So because I will finish this demonstration part. Okay, perfect. And similarly, see here, you can, by using this angle button, I can change the bond angle and you can measure it. For that, you have to choose 3 items. Let me select these 3 items. See, now you can just select 3 items. Okay. And now see here, if you want to change the bond, you can just move it here. See, now you can just make it like this. So you can change it like the bond angle. And even if you want to here also, you can fix some particular group and you can rotate also. You can make it also. Okay. I intentionally I did, because now if I do it cleaning, so it will change. Now see, it was like this. Okay. Now the bond angle, bond length is not proper. And now if I click on the clean button, see, now it was changed. So just to show this one, I have just intentionally, I changed the bond angle. And if you want to change the dihedral angle, you just select this button and select any 4 atoms. And this window will be pop up here. So now you can just change the dihedral angle. See, you can rotate your structure from, you can rotate it. And even also you can fix it here, which atom you want to move and which atom you don't want to move. You can do that one also. And here this along like which direction you want to see, you can select everything here. So various options are there here, but let me cancel this one. And here, see, this one is like inquiry. If there is any kind of things are there, you can just click it here. See, it will show particular, if you want to see the atoms here, if you just click cursor here, and at the bottom, it will give the information. What is an atom? What is the position of that atom? Okay, you will get it. And if you want to add the hydrogen here, so let me see, if you click here, if you want to add more hydrogen here, see, you just select this button, see, you can add it. How many hydrogen you want, you can just add it. Okay. So like that, you can add the set up the valency by using this button. And if you want to delete any particular atom, so what I will do, just select this button, delete button, and you just delete it. Delete, delete, and delete. Like that, you can delete it. Okay, by using this button. And by using this button, you can just, I think, rotate one. This one is. Let me. So there are some questions. So there is a question here. How to attach additional aromatic structure in this structure, then how to write the catalytic reaction mechanism using the simple organic reaction. So I will tell, that is like catalytic reaction is a very advanced stage. Okay. So now we will go by step. So we have to learn the basic things, then we'll go for the catalytic reaction. I will talk about the how to draw the reaction, how to do the transition state. That is the last day. Okay. I will come step by step. No need to hurry. I will show, like there is some participant asking like how to attach the aromatic structure for this one. I will show. No need to worry about that. First, let me explain this one. And this is like if you want to select you click here and you can select the atom, like whatever the atom you want, specific atom, you can select it. And like if by clicking here, you can select all the atoms. You can do that one also. And by selecting here, like if you want to deselect all the things, you can just click on this button. And if you want to select all the button, you can just click here. Okay. So there is one question like, what is the inquiry button? So inquiry button is nothing but if you click here, if you select this button here, and if you keep it here, so it will show at the bottom. See, at the bottom, you just observe here. If you keep the cursor there, it will show what is the atom, that is, whether it is oxygen, carbon, it will show, and what is the position also, it will show. If you like see, it will show the position, everything. And here, I think if you want like symmetrical view, so like you can keep it like this. And if you want to see as a symmetrize your structure, you just click here, automatically it will arrange according to symmetrize. And these are like not that much important. That is like builder button, all this you will get like what is their window, explain everything, explain. You can get the all the like what is their role known as palettes. Okay, so this is about the build. Now let's consider we are done with this one. Now let's consider if you want to attach some aromatic ring to this one. Okay. In that case, you just double click here and choose the ring from here. Benzene ring, select like selected here. And if you want to attach here, you just keep cursor on here and click it here. See? It was done. So what is this? Benzene and oxygen CH3. So methoxybenzene, right? So it is a methoxybenzene. And let's consider if you want to add some other group, like if you want to add the amine group here. Otherwise, if you want to add it here, amino group, what to do again? You just go to the periodic table, open it, and select the nitrogen here. So nitrogen, okay. And I want to add as a NH2 group. Select this one and keep it here. See, now it was added NH2 group. Now it become 4-amino methoxybenzene, right? 4-amino methoxybenzene. And let's consider if you want to add some aniline ring. Let's consider if you want to add pyridine ring here. In this position, you just select your pyridine ring here and you just keep it here. Now see. And you just click on the clean button. It will clean up your structure. You can add that one also. Similarly, if you want to, like there are multiple like heterocyclic ring, aromatic is ring, there same thing, similar things, the same procedure, you can select it. And if you want to show like cis and trans, you can use this one. This is like fullerene, all those kind of things, you can use this from here. And if you want to add some specific functional group, directly you can use this group. You can choose what kind of functional group you want to add here. Like if you want to add the carboxylic acid, you can choose it here and let me add it here. Like, see, you can add the wherever you want, you can just add it here. Similarly, like consider if you want to add some biomolecule, if you want to attach some amino acid here, you just double click here and choose what kind of amino acids. Let me, amino acids only, let me go with anyone. Go with aspartic acid. Okay, and then if you want to attack here, you just click here. See, so you can do like this. So you can draw all kind of structures here by using these things. Let me, yes, close this one. Let me select this one. I will just delete everything. And let's consider if you want like fullerene type of things. Yes, let me go here. If you select here, see, like fullerene type, you can do the calculations also here. Okay. And if you want to do some kind of, if you want to, but I won't suggest, but if you want to perform the calculation by using the Gaussian for the solid materials or 2D materials, okay. In that case, you can draw the structure, or you can just download the zip file and you can upload it. I will show that one also. But there is one of the participants, they're asking that how to remove the molecule if you have added by mistake. Let's consider what I will do it here. I will just draw this benzene. To this, I will add anything kind of like cyclopentene. I will add this to here. Let's consider I added this one. So you don't want to add, if you want to remove. So very simple, either you can just click here, undo button. Okay, or you just click on the Control Z button. Okay, that's it. I hope it is clear to you. Yamini. Okay, and now there is one question from the Rakesh, like how to draw the 2D materials. So what I will suggest, it is very difficult to draw the 2D materials by using the this Gauss view. So what I will tell you, you just download the zip file. Okay, you download the zip file either by using the material projects or by using the ICSD database or C2DB database, and you can upload it. Let me show that one. I hope it is clear to you, this option. Other calculation after I will show you tomorrow, but today I will show you how to, if you want to add like 2D materials or like some kind of solid materials or zip file, how to do that. Let me show it here. So Control Z, I will just minimize this one. So there are various databases are there. Okay, you just open the Google Chrome. Either you can go to the material project also, or you can go to the ICSD database also, or you can go to the C2DB database also. Okay, for the bulk structure, if you want to download the bulk structure, material project is the best option. Okay, if you want to download the 2D materials like graphene or M.Sc, in that case, C2DB is the best database. Let me go to the C2 database just to show you one structure. Just type C2DB and hit the enter button. So once you hit the enter button, it will be redirected to this page. Just click on the first link, that is C2DB DTU, and it will be redirected to this page. So here you need to provide the detail. For example, if you want the graphene structure or molybdenum disulfide or titanium oxide, anything you can just give. I want to the graphene structure. I will just give the carbon, and like number of spaces, I need only one spaces. All the structures should be carbon, and you just click on the search button. Even there is a different type like A type, AB2 type. AB2 means A layer, B layer, B layer. ABC means A layer different, B layer different, C layer different. You can just, there are all the layer I want, and you can give the Bravais lattice. If you know, you can just give the Bravais lattice. And if you know the magnetic property, whatever the material is magnetic, if you select yes, otherwise no. If you don't know, you just leave it. And if you know the stability, then you can select yes. If it's stable, if it's not stable, then select no. If you don't know, you just select no. Otherwise, you just give it here. It will give both. Okay. And like structure origin, if you know, you can, but it is quite difficult to you. You just skip this part. And energy, like you have like specific energy range, you can just give it here. And if you want to download the structure from the specific band gap range, in that you can just select it from here. Okay. So there is one question from Sachin Kumar, how to draw the another ring that are not available in the ring fragment window. So you need to draw, you have to modify. Let's consider if you want to, let me first finish it. I will show you also that one. Okay. So here you just click on the search button. Once you click on the search button, I have selected the carbon. See, it was given list here. So there is C2, only one structure is there. You just click here. Once you double click here, it will be redirected to this page. Here you will get all the information about that one. See, this is the carbon 2D structure here. All the information, you have their space group, everything, their lattice, atomic property, the lattice coordinates, the wake-up factors, okay, atomic position, everything is there. And if you want like crystal information, if you click here, you get all the information. If you want to information about their stability, you can get it from here, their phonon calculation, convex hull. If you want to their tension property, you can electronic band structure, like you can click it here, band structure like DOS, and by band structure by using, there are different functionals they have used here. If you want to know their electronic properties, you just click here, optical properties, just go to this option like optical polarizability, you can get all the information here. And by performing the DFT calculation, you can find out all these properties for your material. Okay, you can predict the optical property, like if you want like Bradard charges, you can find out. So verifies, you can create all these kind of diagrams by performing the DFT calculation, like band structure, density of state. You can do this time. Okay, so now to perform the calculation, you can just download this structure. How to download? You just click on the zip file. So here you can download it in 3 format: XYZ format, zip format, JSON format. Let me download it in the zip format. So automatically it will download. It was downloaded here. Now let me open this structure in the, I'll just close this one and open it in the here. Let's come back to the software here. Okay. So now to open the structure, either you can directly click here on the open button, or you go to the file and you can just go to the open, and you have to navigate to the folder where your structure is present. In my case, it is present in the download. Already I'm in the download. This is the downloaded structure. Select it and click on the open button. See, automatically it will upload it. So this is the primitive unit cell. So this is a primitive unit cell of the graphene, and you can use it for the calculation, and you can build the layer also. By using this one, you can build the layer. by using, there are some layer option is there. You can select how many layers you want, and you can do all those kind of things. Okay. Like all kind of like 2D structures, you can upload it here. And if you want the bulk structure also, you can download it from the materials project and you can upload your structure for 2D materials, all those kind of things. Okay. And this is a periodic boundary condition. If you want to change any periodic boundary condition, so there is an option, like you can use this option, periodic boundary condition, and you can see here, you can change that lattice dimension, like what kind of lattice dimension. So minimum lattice triclinic, you can choose here also. And the cell size, you can just change alpha, beta axis, everything you can change, view option, everything you can reduce it here by using this periodic boundary condition, all those kind of things. Okay. So like that, you can open the 2D materials. I hope it is clear to you. I think this was asked by the Rakesh. Okay. Now there is one more question from like Sachin Kumar, like how to draw the ring, which is not there in the this already like default ring. If it is not there, how to? Let's consider. Let me go to the builder option, view, builder button here. Let me go to here. Let's consider I want to draw the structure of like pyrimidine. Pyrimidine is not there, right? So in that case, you just choose benzene, draw it here. So pyrimidine means nitrogen, nitrogen, nitrogen. So select, now we come back to here, periodic table, and then select the nitrogen here, nitrogen, nitrogen, nitrogen. That's it. Okay, so like that, you just replace it. You have to modify the same thing. You just select it here, similar ring, and you can just do that one. I hope it is clear to you. This was asked by Sachin Kumar. And there is one question from Mazida. Sir, how to draw the doping element in a crystal? So here, I think quite difficult. Better in that case, you have to dope by using your Vesta tool. Okay, Vesta, either you can use the Vesta or Burai. Those are the free tools. There you can do the doping also. Otherwise, some free tools are there. I will show it. Okay, if you want that one, like doping also, defective structure also, I will show, because it will take around 30 minutes. I want to explain everything. I will show that one. Doping, if you want to like how to dope the crystal structure, I will show it later tomorrow. Mazida. So there is a question, one more question from this Sachin Kumar, like how to attach another ring system. So here, see here, usually the thing is that there is control set. Let me show. I think you are asking about this kind of thing, this benzene ring. If you want to attach one more benzene ring, usually whenever you use some software, like if you want to attach one more ring here, you can directly like see here, you can, if you click here, it will attach here, but in here, it will like overlap. So that is a problem with the Gauss wave here. So you can attach this part, but if you want to like fuse the ring, it is quite difficult here. In that case, so better to use some external tools. Free tools are there. You can draw the structure there and you can upload it directly. I will show that one also. In that case, it is not preferable, but if you want to add that one, there is a process. Sometimes it will work. Sometimes let me show it here. You just click on this window, see here, and yeah, it is not working here. In that case, fusing option, this one is not better option. So for that, I will give one more alternatives to you. Free tool only. Either you can use the ChemDraw, ChemSketch, but no need to install any software. I will give one free web server. From there, you can draw such kind of structure. Samruddhi, I will get back to you. Let me finish the session. After that, I will get back to you. You no need to worry about that. Okay, I will solve your problem. And there is I'm facing problem with opening the software. Okay, Samruddhi is done. And Sachin, okay. Let's consider if you want to draw the structure, like if you are facing problem to draw it here, okay, you can draw the structure by using the external tool like ChemDraw, ChemSketch. If you have, you can use that one. If you don't have any those kind of software, if you want to use the free tools, okay, I will show it here. And there is one question from Mazida. We have draw structure from another software, means Vesta after can find DFT calculation. Yes, you can do that one. Okay, now let me show that. For example, if you want to draw some structure and you can upload it here. For that case, let me go and show one thing here. Let me close here. Okay, open your Google Chrome and you just type mole view. Yeah, you just type mole view and hit the enter button. And you will get this page. You just click on the first link, that is a mole view, and automatically it will take to this screen. So by using here, I can draw all kind of structure. like all like chemical structure, protein, enzymes, biomolecules, like different like ribbon form, cylindrical, B factor is there. So I think this is the structure of like yeah, bicyclic nitrogen. It is caffeine, right? So it is the structure of the caffeine. See, like that you can draw the structure here. You can save it directly. Let me save this structure and let me open it. And if you want to save this structure, you just click on this tool button, click on this tool down arrow button, and you just click on this mol file. Click on the mol file. Okay, once you click on this mol file, automatically it got saved. Like mol view, it was selected. I will show it later how to show you this one. Let me show how to draw the structure here. Same, it is like similar to your chem draw only. If you know how to draw the chem draw, like let's consider if you want to take benzene here, draw it, naphthalene, anthracene. Okay, you can just do it. And if you want to make some changes, you select wherever you want to do some changes. You can do it here. Okay, and like if you want to convert it to the 3D structure, you just click on this 2D to 3D. So it will convert to your 2D to 3D structure. Okay, and you can just save it. It is very simple, like similar to ChemDraw. I don't want to extend more time on this one. You can use it and you can do this thing. Mole view. It is like free tool. You can do all kind of work, like what are the work you can do by using the ChemDraw, like you can do the 70% of the work, and it is a free tool. Even no need to install. You just enjoy this web server. Let me close it here. It got saved in the downloads. Let me show how to open that. So whatever the file you have downloaded, open your software, then go to the file, click on the open. So this is our downloaded structure, right? moleview.mol. You just click here and click on the open button. See? So like that, you can just draw the structure by using the mole view, and you can open it in your Gaussian software, and you can submit the calculation. You can perform the calculation. Okay. I hope it is clear to you, Sachin Kumar, and those who want these kind of things. And one question from Amal, in Quantum Expresso, same interface is there. Amal Shashi, I did not understand like what exactly you are talking. In Quantum Expresso, same interface is there, there means like same kind of window to draw the structure, all those kind of things you're talking about. No. Because this Quantum Expresso is a Linux-based software. Okay, so you have to install it in Ubuntu, and you have to either in Ubuntu or command prompt or like Windows PowerShell. So that is like only to execute the calculation. But if you want to prepare your structure input file, for that you have to use the external GUI. Like how we are using the Gauss view for the Gaussian, like for the Quantum Expresso, either you need to use the Burai or you need to use the Vesta. Okay. I hope it is clear to you, Amal Shashi. I think we are already late by 26 minutes. I will just stop it here. So tomorrow we'll continue from the calculation part. I hope today what we have discussed, we discussed the basic concepts of DFT calculation. Then we have discussed the how to download and install the software. Then we have discussed the basic usage of the software, like how to use the different tools of the Gauss view, and then how to use it and how to draw the structure by using the Gauss view. Right? And even if you want to, like, let's see, if you want to represent your structure in different format, you just draw it here and you just go to the view and you just go to the display format here. See, now you just go to the molecule. Now it is like ball and bond type. If you want to show ball and stick model and like ball and tube model, you can just represent in different model, and you can just like wireframe model. Okay, none. You can, it is up to you. You can just do a lot of settings here by using this one. General, and if you want to change the background color also, you can just click it here and you can choose your background color also. I'm just showing it here. Okay, and to keep it like white, you can just keep it here. This is your structure. Okay, there are different quality if you want to increase. So later when we do the result analysis and when we generate the publication quality images, then I will talk about detail in this option. I hope it is clear to you. Okay, if you have any questions so far, from the beginning of this session, please write it in the chat box. So I will check the questions now for 5 minutes. So if you have any questions, please write it here. And Samruddhi, after this session, I will come back to you. No need to worry about that. So any other questions? So thank you, Suhaib. So if you have any questions, please write it in the chat box. If there are no questions, if everything is clear, then type Y in the chat box. So then I will get to know that whether you are understanding it or not. So because basics are very important. If you know the basics, then we can do the application studies. Yeah, perfect, perfect. Most of the participants, they are typing Y. Okay. Okay, if there are no questions, I am just going to end this meeting. I will share the recordings. Okay, within 30 minutes, you will get the recordings. So if you did not understand anything, just go through the recordings once before joining tomorrow's session. So from tomorrow onwards, we'll start the calculation. Okay. So thank you so much for your patience. Okay. Bye-bye. Good night. Okay, definitely, Girish. Okay, from next session, I will go a little slowly. I can understand your problem. Okay. From next session, I will go a little slowly.